Hi, my name is Leon Starr, and welcome to video 3 in the Road Subsystem Modeling series. In this video, we'll take a look at how traffic legally flows on a road segment. Here's an example of two-way traffic. It appears to be flowing normally, and by normal we mean that you wouldn't be surprised to see this pattern of traffic in the real world. So here's a pattern of traffic you would not expect to encounter in the real world. As you can see, it's a highly unorganized and unsafe flow of traffic. But what is it exactly that makes this pattern incorrect? If we look at enough roads in the real world, we can observe a number of rules that are always followed. For example, traffic is organized so that adjacent lanes all flow in the same direction. In other words, we don't see adjacent lanes sporadically reversing direction next to one another, as we did in the previous slide. We do see opposing flows of traffic, but these are organized as sets of adjacent lanes, where all the lanes in the same set flow traffic in the same direction. Finally, there are cases where traffic is so narrow that traffic flows in both directions, with opposing vehicles diverting around each other. So, based on these observations, we can propose three kinds of road segments. In a one-way road segment, we have a set of adjacent lanes, all flowing traffic in the same direction. In a two-way road segment, we have two parallel sets of adjacent lanes. Relative to the ego vehicle, one of these sets flows in the forward direction, and the other, coming back towards us, in the reverse direction. Finally, we have a shared road segment where traffic flows in both directions within a single lane. This observation that a set of lanes flowing traffic in the same direction is a key concept, and we would like to give it a formal name. The word conduit refers to a flow of something, so it seems appropriate. In our model, then, a conduit will refer to a set of one or more adjacent lanes, all flowing traffic in a single direction. And of course, we'll need to formally define lane, but we're going to cover that in our next video. Two-way traffic can be accommodated by pairing up opposing conduits. Now let's apply our concept to each type of road segment. For one-way traffic, we have a single conduit flowing traffic in the forward direction relative to our ego perspective. And our ego perspective is critical here, as we would always want to see that F direction, that forward direction, if we're driving on a one-way street. Two-way traffic requires both a forward and a reverse conduit paired together. Not necessarily adjacent, but running roughly in parallel, and certainly along the same road. And remember that road is a term we defined in a previous video. Finally, we consider a shared road segment. Does it have a conduit? What we appear to have is a single lane with a bidirectional flow, whereas a conduit defines a unidirectional traffic flow in one or more lanes. So according to our conduit definition, no. So let's see if we can model what we have so far. We start off with the road segment class and its various types, shared, two-way, and one-way. Then way over on the right, we'll put the conduit class. And to start off with, we'll just break it down into paired conduits and unpaired conduits. Now we're going to say that an unpaired conduit defines a single flow of traffic on exactly one-way road segment. So in other words, we kind of think of an unpaired conduit as overlaying a one-way road segment and defining the direction of traffic. Looking at it from the other perspective, if we have a one-way road segment, we say that its flow of traffic is defined by exactly one unpaired conduit. Now, a paired conduit is either forward or reverse, and if it's forward, it must be defining the forward flow of traffic on exactly one two-way road segment. And, since it's paired, it has to be matched up with a two-way road segment and not a one-way. And we can make a similar statement for the reversed paired conduit. Taking the perspective of a two-way road segment, we see that we always have one forward paired conduit and one reverse paired conduit. This is thanks to those solid dark arrows, which you may remember tell us that we can't have zero. We must have exactly one instance. So we are enforcing a fairly significant constraint here. And as you can see, there's absolutely no relationship between a shared road segment and any kind of conduit. Later on, we'll want to relate this to some sort of bidirectional lane. An important point about our modeling approach is that we aren't just gathering an inventory of three kinds of road segments or two kinds of conduits because that's what we've seen before. Instead, we are observing and defining universal principles of traffic and road geometry. We are boldly asserting that these modeled elements account for any road on the planet. Now, parts of our model could be, and certainly will be, proven wrong, especially as it gets bigger. But it is our goal to converge on a correct model that accounts for a set of semantic building blocks that can be combined to accurately define every possible road structure that we might see. So far in this series, we've defined the road and its edges, our orientation with respect to the current road and any perceived crossroads, and all possible legal directions of traffic flow. Next, we can take a look at how all of the traffic on a road is managed by incorporating a precise definition of lanes into our model.